Hello and welcome. Right now we're going to look at polynomial regression. We've already looked at linear regression before, but the limitation is that in most real-life applications, you're not going to have a strictly linear relationship between multiple variables. Alright? So what we have to do is try to find curves that fit these relationships better. So I've pulled up Desmos here to show you visually how this curve fitting works. I've initialized 2 points here, negative 1, 5 and negative 4, 2. Alright, so now I've also initialized an expression 0x plus 0x squared plus 0x cubed plus 0. So I've also initialized a polynomial expression here with coefficient 0 being a degree 3 polynomial. So what we're going to do here is try to fit a curve that goes exactly through both these points, right? Because if I give a linear polynomial with the degree 1, I just get a normal line. Now if I give it another degree, let's say the second degree with a random coefficient 2, we finally get a curve. Just like we've seen, with a linear expression, we can only form lines, straight lines. With a polynomial expression, we can bend those lines. So our objective is to bend these lines to fit these points. And we can play around with these values, but I'll just show you the right values from the start so that we can save some time. So we've figured out an almost ideal line that passes through both these points. But what we have to do now is finally add the offset. We can try experimenting here. Right. So what we've done right now is we've built a polynomial expression for a curve that passes through all these given points. The points negative 1, 5 and negative 4, 2. This is just to make you understand how polynomial curves fit through points by bending. Unlike linear expressions where you can't bend curves, you can only form straight lines. Why do we need polynomial regression at the first place, right? So for simple linear models, what they do is they form straight lines. So you can follow trends that are linear, strictly linear. You cannot follow curved trends. So what you're going to have to do is implement polynomial models. What polynomial models can do is they can bend, right? So they can follow non-linear structures, which is really useful because in certain applications, in most applications in real life, just like stock predictions or sales or growth or declines, anything of that sort, you can map it using polynomial models. You cannot map it using linear models because they 99% of the time do not follow linear trends. Now we're going to look at a small code implementation to understand how it works logically. First, we import two libraries, matplotlib and numpy. Then we set up a random seed as a starting point and a checkpoint. Then we start giving our x values. X values, we give a negative 3, 3 interval. So from x value negative 3 to 3, we're giving 50 points, random points, right? So what does the y variable actually do? The y variable is an expression that makes the points follow it. So all the points are going to be around this expression here. So our x cube coefficient is going to be 0.25. Our x square coefficient is going to be negative 2 and our x coefficient is going to stay 1. And finally, we're going to make sure that the data isn't strictly linear following the line. It's going to have a little bit of noise to it, right? So we give this bit of the code here. Next, we're going to use a degree of 1 to understand why we cannot implement linear relationship models for certain use cases. Our coefficients is going to be the polynomial fit of x, y and to our given degree. What this means is that we give our x and y values, we build a relationship according to the given degree. So if it's a degree 1, it's going to build a linear relationship. So if it's a degree 2, it's going to be a polynomial relationship. Next, we're just going to print out the coefficients as seen here. Next up, what we're going to do is form the equation that builds the polynomial relationship. This piece of code here, using the poly1d function from the numpy library, can be used to build that relationship. Next up, we're just going to predict based on an x value. Right, so this is just for plotting. We form a scatter plot with the x and y values. We also form a line plot with the x and the predicted y values. Now, since we gave a degree of 1, our relationship line is going to be linear, right? However, our data points do not follow a strictly linear relationship. They are kind of curving up here. So they go upwards and drop downwards, right? So what can we actually do here? What we're going to try to do is increase the degree of the polynomial and see what happens. Now we see that the curve fits the data a lot better. It understands the meaning of the data rather than just going linearly, right? Next, we'll try to figure out what happens when we increase the degree by a huge margin. Let's increase it to 15. Now we see that the curve is bending so much to the data that it overfits, which means that it basically just memorizes the data at this point. If we increase it more, we can see the effect of this a lot more, right? So it's basically just memorizing every single data point, which is not something good. We need something that follows a trend but does not memorize it, right? So we can just drop it back to 3. It seems pretty balanced. Yeah, it seems pretty good because it's understanding the meaning of the data. It captures enough and doesn't capture more than needed, right? So this is how polynomial regression actually works. Linear regression basically just forms a straight line. So you lose meaning if the data flow is not linear, right? So what we have to do to allow the model to capture meaning is to allow the curve to bend, which means that it can capture non-linear trends, right? This is very useful because in most practical applications, you're not going to have a strictly linear relationship. And this is how it works. And I hope you understood it intuitively and understood how curve bending actually works, how the curve is actually fit with the data using least squares regression, and why we actually need this to be applied in real life. And yeah, keep learning. Curiosity is the only reason we've got this far. And I'll see you guys in the next one.